Welcome to the Guardian Group podcast series. The Guardian Group, providing extraordinary solutions to today's exceptional problems.
Hello, podcast fans. Welcome to another edition of the Guardian podcast series. I'm Todd Comodine, your host with the Guardian Group. My usual cohort, Rick Murrah, is on assignment today, so you're stuck with me. What we're going to talk about today is reverse engineering. Now, what is reverse engineering? It's basically bringing something back to life. And using an example, when a PCB is obsoleted, the customer or the manufacturer may hold on to the photo tools for a certain amount of time. Sometimes, it could be 1 year, 2 years, 5 years or so before it's obsoleted. And, due to storage constraints and things like that, the data may be purged and then it's gone. Today's designs are not as much of a problem because they evolve so fast, and new designs and rev changes, and so photo tools are usually readily available. But if you look back at some of the more robust reliability designs like military and healthcare stuff, you can see that some of this stuff is using PCBs that were built a long time ago because they're real robust and can handle heavy duty cycles, and the equipment is just not in need of updating so much. So what happens is some of these old photo tools disappear, and somehow we want to make sure or have an ability to be able to bring these back. So reverse engineering is a process of recreating the required tools from a finished product. So if you have a board that's still in inventory at your manufacturer, you might have it on the shelf, and this may be could be populated, or it could be basically a bare board. Either one can be used. And the first option for netlist or for reverse engineering or getting the photo tools back is what we call a netlist extraction. This takes the board itself, and we do a learning process. Now, if the board is bare board, it's pretty straightforward. But if it's populated, we'll have to remove, components, and that can be a little bit challenging. But today's tools available to do this make it a lot more easier to do. So if you do have a golden board from inventory, what we do is we use a flying probe. Guardian's line of flying probes are very good at this, and we do what's called a netlist extraction. So the recovery process is basically first we actually have to scan it. So, because we don't know from the beginning where all the pads and holes and things are. So the first thing we use is a scanner, and this is a process using a flatbed, not necessarily one that you would buy at Office Depot or something for scanning your Christmas photos or what have you. These are high pixel rated machines. We have partnered and use a company called ScanCAD. And with this flatbed scanner, we put the board on there and we scan the outer layers. First layer 1, and then we do layer X. Then we go into an editing process where you would look at the traces and holes and all that, and you would, if there's any glitches in the scan, you might have to tighten up a trace or make sure the connections are good. And once all that's there, we can output a footprint where we can then take that to a flying probe and use what's called a self-learn process, where the machine knows all of the pads and holes, but it doesn't know any of the intelligence. So we put that on there, and we tell the machine to self-learn, and it goes out and learns that board by taking the probes out and interrogating each of the pads to make a netlist. And when that is created, we actually have a netlist on the machine. Now, this isn't necessarily in a form right now where you can go build the board, but it does have the intelligence. And so then after that, we do a process of testing against that netlist to make sure that it will pass to what it learned. And if it didn't, we do some investigation. If it missed a pad or if there's some solder mask in the way, all these little things can come into play. So once that is done, then we actually have a net list, and we can actually take that net list and we can send it back to the customer, or you can send it back to your customer or design group where with that net list, usually an IPC 356 type net list, and they can go back and they can run it through their software, and they can actually regenerate photo tools, Gerber layers. They may not necessarily be exact to what the original board layout was, but the intelligence of the board will be the same in its final product, and then they can output the photo tools, and then there you go. We're back to having a photo tool set that we can recreate the board and make new PCBs. Now, the second one of the options that you can do is what's called destructive scanning. We're still using the scanner from what I talked about earlier, but what we're going to do now is we're going to generate the entire photo tool set. So what we do, we start out with that is we take the PCB again, and we scan an outer layer into the machine, into the software, and that will allow us to create the first photo tool layer. And where we change the idea here is where we now take a milling process and we actually mill down on that first layer until we expose the second layer. And once that second layer is exposed, then we do the scan once again. So we create the second layer, and we repeat the process through the different layers until we have all of the photo tool layers created. And then from there, we go back and we manipulate, or what I should say is we actually go through and we check all of the layers to make sure that all the traces are good, and we can bump them up to size. If they want a certain trace and space criteria, we can bump the traces up, we can take them down. If we see any violations, we can make adjustments to connections, to holes and pads and vias. And then once all that's done, we actually tell the system again to recreate the intelligence. So it takes all of those photo layers, we send that into CAM software, because we've created the photo tools or the Gerber layers, and we can take that into a CAM system, and we can regenerate a full netlist photo tool set where you have already the photo tools, the drill files, and even a netlist intelligence. And if you are lucky enough to have a second board, because we just destroyed the first one, but if you're lucky enough to have another board, golden board or assembled board that can be stripped down to the bare level, we can actually then take that intelligence that we have created, and we can go back and we can test that against the board on the flying probe, and that would give us a full double check against what photo tools we created, that they do actually match the boards. And from there, that information, can be sent back to the customer, and then they can actually go and do their PCB manufacturing. So that's one of the two main ways of doing that. And because a lot of times you don't have a bare board, so a lot of times it turns out to be a assembled board that needs to be depopulated. And then you can the best way to do it is to depopulate it and then do the outer layer scan like I mentioned before, and let the self-learn process happen so that you generate an intelligence from the board itself. And then you go through and then do your destructive scanning, creating all of the layers and photo tools, so that you have a net list that you created from the flying probe prior to the analysis or destructive scanning. And then from there, once you have created your photo tools and all that from the scanning process, you can then do a net list compare between the net list that was created from the golden board learn compared to the net list that you created based on all of the destructive scanning. And so when you compare the two, you can find out if your net list is golden or what you create is golden, or it could identify some differences where you can actually go through and look at the layers to see where the actual discrepancy is, because you've created all the Gerber photo tools, and now you can look at both of the options. So when we talk about the tools required, I mean, it can go back. I mean, you can use, to do this destructive scanning, you can use just a flatbed scanner, and you can use, you can use sandpaper if you want to take the time. If it was a 4-layer board or a double-sided board, it makes it rather easy, and you can actually sand down and expose the plain layers. And then with the equipment that you use, you definitely need to perform or find the right software and hardware. I mean, like I said, the flatbed scanners, you want to have high resolution if you're wanting to use create a very good representation of the PCB. And with that comes looking for strong partnerships with your vendors. And if you have your own equipment, the flying probes that can do self-learns, that helps a little bit. But you need to look for good partners. Guardian has selected, we partner, we use the ScanCAD software suite to do our scanning. And we utilize our own flying probes using our Guardian proprietary FPX software for doing our self-learns and creating our netlist for the golden boards. Guardian provides a flying probe line, or G series machines, that have multiple capabilities, including the self-learn, and that's just partially, but we have also the abilities to do 4-wire Kelvin and high pot, inductance, impedance, and of course the standard opens and shorts test. But anyway, you want to make sure that you have good software tools, and if not, partner with a good vendor. Guardian supplies this for you as well. So in conclusion, what we talked about is we talked about what reverse engineering is. It's the process of taking a finished product and taking it back to its roots. And we talked about what the golden board learn extraction process is. That's where we just take a bare board or a component taken cleared board, and we actually do the self-learn on it to create a net list. And then that can be sent back to a manufacturer to run through routing software and design and re-output new photo tools. Remember that may not be exactly what the original design was, but the end result is a functional PCB to the original design. I would say the design criteria, it will function as the original product did. The other thing we talked about was destructive scanning, where we do a self-learn again, recommended, and then we actually do the scanning of the board and mill layer by layer, where we expose each layer independently, scan it, and then from there, when we're done, we have our entire set of photo tools that can be created to Gerber, create our drill files, our solder mask, solder paste, and so forth. That can go back into CAM software, generate film layers and all that for you to regenerate the PCB as well. And then the last thing I talked about was having the proper tools, basically having a strong enough scanning platform to get high pixel resolution, and you want to have the right equipment to be able doing the self-learn or the integrity test of the PCB prior to scanning, and then actually post-scanning if you have the ability to do that to the board, or you can do the netlist comparison between the original self-learn prior to destructive analysis, and then you can compare to make sure that you're absolutely correct or make any adjustments. And then those photo tools are ready for the manufacturer to recreate the PCB. So if you're in the mood for doing some reverse engineering or find an old PCB that needs to be recreated and all the photo tools are gone, give us a contact. You can send a contact to us at info@guardian.com. That's info@gardien.com. And you can look at our equipment lines and what options are available to you by giving us a look at www.guardian.com. With that pretty much concludes our chat about reverse engineering. Glad you stopped by, and I hope for you to stop by again and listen to another podcast from us here at Guardian. From Todd Comodine and the Guardian Group, we'll see you next time.